Just kidding, guys. We are not going to be rumbling because really, engineers and computer scientists tend to be pretty mild-mannered people, but I fear if they ever begin to rumble, there might not be a way to put the lid back on it. So we will not be rumbling, but we will be learning some cool new stuff today because we are here with lesson number 4 in our incredible tutorial series where you are learning artificial intelligence on the Jetson Xavier NX. Now I am going to need you to pour yourself a nice, big, enormous mug of iced coffee. And I am going to need you to get ready to learn some cool new stuff. So let's get out our Jetson Xavier NX gear and let's get ready to learn some cool new stuff. Hey, if you don't have your gear yet, check out the description down below. I have links over to Amazon so you can pick up the identical hardware that I will be using in this series, and it will make your life easier and my life easier if we are working on the same set of hardware. Also, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It's your help and encouragement that keeps this great content coming. You guys that are not helping out yet, look in the description down below. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's talk about what we are going to learn today. We are going to learn Gstreamer. Yes. And I have to say, this is one of the hardest things that I have ever tried to figure out because all the tutorials out there assume that you already have a tenured position in the computer science department of MIT. And it was very hard to kind of break it down into how can I use this or how can I actually take advantage of this tool. And if you were here for lesson number 3, you have already done your first Gstreamer commands, and I will just pop that window open. And that was this long and tedious command here, which we put in this long and tedious string, which we put in last week to allow us to fire up the Raspberry Pi camera. So if we run this program, it launches the Raspberry Pi camera using Gstreamer. Boom. Okay, and what it seems like is somewhere out there at some point along the way, some guy figured out this huge long string that if you launch Gstreamer with that stream on the Jetson Nano or the Jetson Xavier NX, then magically the Raspberry Pi camera would pop up. But the problem is it is really, really confusing looking at that. And the problem is if we just go and run someone else's command, how do we know that they really know what they're doing? How do we know that we are running as fast as we possibly can? How do we know if we're running at as high of a resolution as we can? How do we know if we are getting the highest image quality that we can? Answer is we don't. We just copy and paste what someone else does. What we're going to do today is we are actually going to learn how to use Gstreamer. Now, you're not going to be the world's leading expert when this is over, but you are going to know enough that you can squeeze a lot more performance out of your work when you are using Gstreamer in OpenCV on the Jetson Nano or Jetson Xavier NX. Now, this work that I'm doing, I am doing it in the context of the Jetson Xavier NX. It would work exactly the same on the Jetson Nano. And really, it would work the same on any system that has Gstreamer installed. If you have the Jetson Xavier NX or the Jetson Nano, it is already installed on your system. If you have some other Linux machine, just look it up. It'll be just a simple command that you'll give to install it. You'll have to kind of figure that out based on what system you're on. If you are on a Windows machine, well, I can't help you. You're hopeless. If you're using Windows, I'm sorry. You're on your own. But I will show you how to do it. Also, this ought to be able to run, a lot of this stuff ought to be able to run on the Raspberry Pi for you guys that are playing along at home with a Raspberry Pi. So what we're going to do is we are going to learn Gstreamer today. And let me start by just kind of giving you an introduction to say, what is Gstreamer? Well, in the real world, we have cameras and we have displays. And then we got to do something to go from a camera to a display. And usually it's not as simple as just plugging the thing in, because there are a million different cameras which have a million different formats and a million different resolutions and frame rates and encoding and decoding and all this sort of stuff, and then a million different displays. And so it would be like if you just had a hardware store full of millions and millions and millions of screws and a hardware store full of millions and millions and millions of bolts, and you're trying to get them to work together. It can be kind of tedious. So what is Gstreamer? Gstreamer is creating a pipeline that will go from a source, like a camera, to a sink, like a display, okay? And now there are more than one sources. The most obvious source would be a camera. But what could another source be? Another source could be a file, or another source could be a stream, like a UDP stream or something, where you have data streaming in. It could come from a file, it could come from a camera. And then similarly, you could stream out, or you could go to a display. So there's different sinks and there's different sources. And Gstream is all about creating a pipeline from the source to the sink. And we've got to start thinking in terms of these terms. They mean something. Source is something like a camera. Sink is something like a display. Okay, so this is the way to look at it. You're creating a pipeline, but it would be like, and you got to get it all to match and all to fit together. But it would be sort of like this. Imagine that if you're starting at one end with a pipe, and the pipe was huge, like 3 feet and square. And then imagine at the other end, you wanted something that was round and small. So you got to go from huge and square to round and small. Well, you might say, okay, we'll use an adapter. Yeah, but the problem is you can't find an adapter that goes from huge and square to small and round. So the way this works is you would maybe go from huge and square to medium size and square. And then from medium size and square, you would go to small and square. And then small and square, you could go to small and round. So you would have adapter, 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 adapter. And you usually can't make that trip with just one adapter. You've got to stack them until you get something that takes what you have from your source and get something that will work with your sink. Okay, now I'd mentioned displays are an obvious sink, but in the context of the work that we are doing in OpenCV, the OpenCV application itself is the sink. Okay, so let's go back and let's look at that command that we did last week. It ended up with what? I hate that. It ended up with app sync. So that's the application, OpenCV, as a sink. So you configure this pipeline and it dumps the video stream into OpenCV in a format that OpenCV was happy with. Okay, and so it's about building these pipelines. And this is a little bit different because as programmers and engineers, we think in terms of linearly giving commands, like you would write a program to do this, do this, do this, do this, and you give a sequence of steps. This isn't that way. You are constructing a pipeline in one line of code, and then the data goes down that pipeline, and it goes in one way and comes out in a different way. It goes in what you're getting from the camera, and it comes out in what you need for your application or for your display. Okay. Enough of this pontification, and let's jump in and let's learn Gstreamer. Okay, I will need you to open up a nice, fresh terminal. And there's a quick install that I'm going to have you guys do. And that's just because I'm going to be working today with both the Raspberry Pi camera and the webcam. And when we're using a webcam, you need to kind of know what the parameters are possible with your webcam. And so there's a quick little program you need to install. And so you need to do a sudo apt get install. And it is v4l-utils. v4l-utils. Okay, that is looking pretty good. And since I already installed it, of course, my install probably went a little bit faster than yours did. But nonetheless, you need to go ahead and get that installed. Okay, and let me clear that. I am going to do a tiny bit of Windows management here to make sure that you can see this good. Okay, so we talk about these pipelines. You go from a source to a sink, and then you do things in between. If the source doesn't match the sink, then you have to do conversions. All right, but let's just do, and this, got to tell you, this will work for audio and video, and actually it will work for just about any type of data, any type of streaming data you can build Gstreamer pipelines on. So it's a very, very powerful but very daunting piece of software to learn. So let's look at the very simplest thing. Let's have a source, an audio tone, and let's have a sink, a speaker. Well, I will do a GST-launch, GST-launch, and then a dash 1.0. So we're using Gstreamer. We're going to launch it in version 1.0. Well, what I want is an audio test source, okay? And then I'm going to pipe it to, exclamation point is what connects one module to another module. So my first module, my source, is an audio test source. If you installed Gstreamer, I'll give you a heads up. You already got this. Okay, so don't worry about it. It's just kind of like for demos. It's a source, so we don't have to go out and worry about what kind of microphone you have or something like that. We'll just use the audio test source. And then where are we going to send it? We are going to send it to ALSA sync. So this would be like audio something sync. So we go from our source, the test tone, to our sync, and then we click enter. Boom. Do you hear that? We have a source and we've connected it to our sync, and we have sound coming over our speaker. Okay, so that is about as simple of a thing as you can do. But now, how do we really start learning? Because this is, again, back to the example I gave you before. I know what I'm doing, you don't. You just copy what I do, and you're never going to be able to do anything on your own. What I'm going to show you here is the secret to starting to build these pipelines instead of copying other people's. You've got to know how to inspect the element and then see what parameters you can set on it, like what formats it knows and what things you can set. And so I'm going to give you a new command. I gave you the GST launch. I'm now going to give you a command, gst.inspect. Okay, and we're going to do audio test SRC, audio test source. So we're going to go in and we're going to look at that module, okay? Whoa, audio inspect, I'm sorry, GST inspect dash 1.0. Okay, GST dash inspect dash 1.0 audio test source. And look at all this stuff here, man. Look at all this stuff. So I'll kind of take you through this. This very top stuff is just kind of like names and stuff like that, who developed the plugin and some different things like that. And then what really sort of matters is where you get down to the source template. Okay, so remember, you have two things. You have sources and you have sinks. Now, a converter module would have on one end a source and on the other end a sink. Okay, but something like a tone or a microphone or a camera, it is just a source. But the source of the camera feeds into the sink of the next block. And then so the sink of a block is kind of like the input. And then on the other end of that block will be another source. Okay. And then that source will go to the sink of the next block. And then it will have a source that will go to the sink of the next block. So what you got to see is that a sink is like an input to a module, and a source is like an output. It kind of seemed backwards to me. It took me a little while to really kind of get comfortable with that notion. And I need to, okay, you know what I am going to do today? Yes, I think I am going to, give me just a second here. Give me a second. I know these lines are like really long, so I'm going to turn that off like that. Okay, and now I think I will also probably get further out of your way, and I'm going to make this window bigger because those lines are kind of long there. This window kind of doesn't want to resize today. Okay, and once again I have the sticky window problem where it has decided that in fact I hate that I'm really wanting to resize this full screen, which I do not want to do. Okay, that looks pretty good. Okay, so all this is just background information on your source, which is your module, which is audio test source. But this is what you want to see is you want to come down and look at the pads, because the pads kind of tell you what the capabilities are. So the first pad is the source. All right. Now, you can imagine for a tone, you only have a source. You only have an output. You don't have an input. So this has an output pad, but it doesn't have an input pad. And what you can see is that you can now look and see the formats that it can put out. It can put out audio x raw, okay, as the kind of upper level format. And then within that, there are all these different formats that it can use. Okay, so that's kind of telling you what it can do. All right, this is telling you what it can do. Now, what you really care about are the properties, and the properties are the things that you can set. Okay, the properties are the things that you can set. Okay, and so you can see here that the things that we could set on this module through the command line is we could set the name or the parent, block size, number of buffers, type find, do timestamp, wave. Okay, so now here's all of a sudden something we might be interested in. We can set what type of wave is generating the tone. You could set a sine wave, a square wave, a saw wave. We could do different things like that. And so that would allow us to adjust, and you don't really audibly notice a lot of difference, but you can tell a little bit of difference depending on the shape of the waveform. So how would we do that? Well, we say, let's see what a square wave is. A square wave is the number 1. Now, default is 0. So if we don't put a parameter, we're getting a sine wave. All right, so let's come here. And let me remind myself what that was. It's wave. And so if we just come and run it like this, if we just come and run it like this, we are going to get a sine wave. Okay, it's pretty smooth sounding. Okay, but if we come here, we can put the parameter in. After audio test source, what was the variable? Wave is equal to, let's set it to 1, which was the square wave, and now let's run it. Okay, wow. That's a lot harsher sound, the square wave is, than the sine wave, so you really could tell a difference there. All right, now I have to show you something very, very important. When we are setting these parameters, I am going to try to adjust this a little bit on the fly here. Okay, that'll put me a little bit further out of your way. All right, so when we are adjusting these parameters, here is the module, audio test source, and now we're going to set a parameter. We put a space, not a comma. Okay, so audio test source, space, wave, equal 1. I didn't like that. I'm going back to wave equals 0. Let's see what else we can set. Oh, look, we can set the frequency. Okay, the frequency will control the tone. So let's come down and let's set the frequency. Again, between parameters, you put a space. So we'll put space, frequency, and let's say is equal to 800. That's very high. Let's put 200. That's very low. I don't know if you can hear it. I can hear it. Let's go to 300. Okay, so we can control the frequency. Let's see if there was anything else interesting there. I thought I saw something else. Volume. Okay, so the volume parameter will go from 0 to 1, and the default is 0.8. Okay, it will go from 0 to 1, and the default is 0.8. So if we want it louder, we will say volume is equal to 1. All right. Notice we have spaces between all of our commands. You know what I think I'm going to do? All right, yeah. So I can detect that that is louder. I'm going to move this up like this, and that way you will be able to see the whole line. Like that. How you like that? I hope you like that. Okay, we've given our first Gstreamer command. Okay, so the key thing is when you're setting parameters, you put spaces between what you're doing. Also, very important, you have to have a space between the exclamation point and the next module. If you put the next module without a space, it doesn't work. And so this is really kind of very tricky. You've got to get this formatting very, very carefully. So number one, when you're listing parameters, you put a space between them, like here, and here, and here, and here, and here, and spaces. In a minute, we're going to be setting those caps that I showed you a while ago. Darn it, when you're setting the caps, you use commas. And so you've got to keep this straight. Commas when you're doing caps, and spaces when you are doing parameters. And let's go back and look at that program that we did last week. Okay, so you see here is the module, all right, and then here is the parameter. We use a space. And now this exclamation is going to the next module. No, this exclamation, what this is actually doing is this is setting the caps. And so this is the other strange thing. Sometimes the exclamation point is taking you to the next model, and I have frozen up. I will fix that post haste. Okay, there we go. I'll try to be mindful to watch that. It's just, I've got so much USB stuff going on here, my USB line freezes sometimes. Okay, so you can see that sometimes this exclamation is taking you to the next module, and sometimes the exclamation is setting the caps or the filter for the existing module. And the way you look at it, like when we looked up there on those caps, it listed like 100 different formats that it puts out. Well, on the caps, you put the exclamation, and of the 100 it can put out, you tell it which one you're going to use. Okay, so you're sort of setting those capabilities, but that happens after the exclamation point. And so we are telling it here that we wanted video XRAW memory for the format, and then a comma in the size, and a comma in the height, and a comma in the frame rate. So if you're setting caps, you've got to put commas between the commands or the parameters. If you're setting parameters, you use spaces. And just to understand this is really, really important. And as I go through the examples, it's going to be more clear. All right, so we look here. Audio test source had a parameter of wave and frequency and volume, and all of those are the space. Here we're not setting caps. We're just going directly to the next module, which is ALSA sync. Okay, I hope that makes sense to you. Okay. We changed the frequency a few times. We looked at the parameters for the audio test source. Okay, so let's go back and let's look at those parameters again. Okay, so I can go back up to that GST inspect. All right, and we're going to look at audio test source. And one of the things that you see here is you see under caps, okay, that's it's under what they're calling pads here, or the element properties. Okay, this is what we call the capabilities, the caps, or the properties. And I am misspeaking here. Here it is. Caps are capabilities. I misspoke. Caps is short for capabilities, which would make sense. Okay, so you can have audio X raw out, and that's kind of the only option. But then for format, you can do S16LE, S16BE, U16LE. You can do all of these different formats. But what you got to ask yourself is, what format does ALSA sync want? So we better look at that one. Okay, so we are going to look at ALSA sync. ALSA sync, and then we can see that this is going to be a sync, so it is not going to have source caps, it's going to have sync caps. And so let's look at this. You can see the pad template is sync. Okay, and then here we are with capabilities. And what does it like? Well, it likes S8. Again, good news is it takes audio X raw, so we're not going to need a converter in there. We're not going to need an extra module. We can feed directly from the source to the sync. But what we have to make sure is that we're outputting from our source something that can be read by the sync. And we're looking at the sync now, and we can see that the sync will take U8. Okay, there's probably others that will match, but I see that it takes U8. And then I also see that if I go back to the source, under capabilities, it has U8 as an option as well. Okay, so we can get a little bit more sophisticated in that we can do the GST launch. We can use wave is 0, frequency is 300, volume is 1. But now let's set the caps for the video source. How do we do that? Well, we put the exclamation, and so now in here we are going to set the caps. Now there's two things we could do in here. We could put a whole new converter, or we could set the caps for the previous module. We're going to set the caps for the previous module. And what do we want? Well, the format that it would do was audio over X-raw. Now what do I do here? Do I do a space, or do I do a comma? This is a cap, so I do a comma. All right. And now what do we want? We said format equal U8. Okay, format equal U8. Does that make sense? It really should. Okay, so we're taking that audio test source and we're putting this format on it, and then we are dumping it to the ALSA sync. Ooh, that should have been an equal, not dash U8. Hopefully you guys caught that. Okay. All right. Now we're getting the same tone, and we don't detect any difference in the tone. But what we've done here is, and it's Control-C to kill that, in case I didn't say that, Control-C to kill it. What we did there was we did it in a format of our choosing, and that's important because for other syncs, it might need a certain format. So we're giving the format of our choosing there, okay? So that is pretty simple. Okay, let's try another one. Let's come in and let's try U18E. Okay, let's do format U18E. Oops, what did I get? I got an error, and I got an error. Okay, I'm sorry, because that's not one at all. It's U18LE. Okay, and here I got an error, and that is because, let's go back and look at those capabilities for the audio test source. Okay, inspect audio test source, and let's look of all the ones that it will do up here. It does U18LE, Okay, so it can produce that, so that did not generate the error because that's good as far as it can produce it. So let's look at our cap of our, or let's look at our inspect our sync. Okay, like that. And now let's see what formats it can use up here. Okay, I see U8, I see U16BE, I see S18LE, but I don't see U18LE. Okay, so that is where the problem is, that I chose something that wasn't going to work. All right, and so that was let's go back. Where was that? U18LE. I get an error. It can't make that. The output and the input are not matching together correctly. All right. So watch this though. I've got an output or a source coming from the audio source, and the sync doesn't like it. So what do I need to do in order to make that work? I need to do an audio convert. Okay. And here I'm going to add. So this is the module audio test source. These are the caps that I'm setting on it. And then before I go to the sync, I need to what? I need to put a converter in here. And so I'm just going to do space audio convert. And sometimes these audio or video converters, they'll figure out this guy's giving me this guy wants this, and they'll figure it out and kind of get something to match. And you don't have to put any parameters. Boom. Okay. So I took something that wasn't working and I made it working. I made it work by putting in this additional module of audio convert. Now this one is kind of smart, and it saw what it had and it saw what it needed and it made a match. But usually what you would do is you would come in and you would inspect audio convert, and you would look at its capabilities. These are its sync capabilities. These are its inputs. Okay. And if you look at it at its inputs, it will take in here somewhere U18LE. Okay, it will take that in, and then it will put out whatever it was that audio sync wanted. Okay, but normally you would look at the inputs and look at the outputs, and you would set those as capabilities, and therefore you would get the conversion that you needed. Okay, well, let's keep moving right along here. And I don't mean to belabor the point, but it's just an audio source and an audio sync. It's so simple. And if I can get you to understand how it works with something really simple, then when we go back and we look at that mess that we had in our Python program, it'll begin to make sense. If you don't understand something, figure out what the module name is. Go and do a GST-inspect-1.0 on it. Look at the caps. See what it wants as an input. See what the caps are for the sync. See what the caps are for the source. And then, do your magic. Okay, so let's move right along here, and let's see what else we can do. So we did an audio convert there. Okay, and actually what we can do is we just kind of let the audio converter figure it out. But here I'm going to show you how I can set the caps. And so we've got coming in as the input U18LE. And then what we knew that AL sync, what it liked was U8. And so what I can do is I can come in and set the caps or set the filter for the audio convert module. And remember, mindful to put your space in there. And we are going to still stay in audio X raw. Okay, we're going to stay in audio X raw. And now we're setting caps. So what do I need to put? We're setting caps. So I put a comma, not a space. And then format equal U8, like that. So I'm taking U18LE, which ALSA sync does not like, and I am audio converting it to U8. Boom! Look at that. Okay, so you're converting your inputs to your outputs. That's kind of neat, isn't it? Okay. Enough of this audio nonsense. If I have an audio test source, what do you want to bet that I have? You can bet that I have a video test SRC, video test source, and I'm going to pipe that directly over to X image sync. Okay, let's see if we can get lucky like we did with audio. We're just taking the test source and we are piping it to the image sync, X image sync. Okay, boom, look at this. We got the happy little test bars, and you can see it's live video because you kind of have snow down here. I think that is pretty darn neat. And so we got lucky that one of those formats that video test source outputs is one of the formats that XImageSync can read. And so sometimes when you're doing simple little demos, this works, but never in the real world. In the real world, you got to do a lot more than that. But the first thing let's do is let's go in and do a GST inspect on 1.0, and let's inspect video test SRC. All right, let's see what we can do there. Hey, there's a flip method, there's a motion, there's an animation mode. There's a lot of stuff that we can set here, okay? And these are all properties or parameters, right? These are all properties that we can set. So we would do that without the exclamation and just using the spaces. We could set quite a bit of interesting things. And I think one of the things that we might want to do is, it looked like pattern was interesting. You see, we can set all these different patterns. Okay, look at that. There's a circular pattern. Let's see what that looks like. All right, let's see what a circular pattern looks like. So we are going to come here, and it is a property. It is a property, right? So how do we set that? We set the parameters here. Space PATTERN is equal to, I do believe I said 11. Okay, look at that. We got that circular test pattern by setting our parameters. Okay, by setting our parameters. Let's go back now and let's set our pattern back to 0. And let's go in and let's set the capability. All right, so I guess we probably are going to need to inspect that again, or we just inspected it, right, this video test source. Let's go up and look at what the capabilities are, or yeah, the caps. So we'll come up higher, and this is just a source, okay. Go up higher. So this is only a source, and here are the caps, here are the capabilities. All right, so we can get a video XRAW out, a video XBayer out, and then we have all these different things. And like you'll probably recognize, BGR is blue, green, red, alpha. XRGB is sort of just a 4-channel, but it gives you RGB. I think the X means nothing is really being used there. And so you can have gray 16-bit, you can have gray 8-bit, you can have NV21. NV12 is one of the ones that NVIDIA uses a lot on some of their commands. So you can see that there is a whole lot of things that you can do with this source, but we could choose between video XRAW, and we could choose between that and, I thought I saw another one, video XBayer. Right, so those are the two choices of what we could set. But let's try the following. Let's set those caps, because, you know, like I say, in the real world, the output never matches the input. So you're going to have to learn how to do conversion. So we're going to do that. We don't have to do a video converter. We're just going to set our caps. So we're going to say video x raw. And these are caps. So what do I use? A comma. And then format equals BGR for blue, green, red. So let's see if that works. Okay, it did not image sync, Ximage sync did not like BGR. So either that or I made a typo. Video X raw, that looks pretty good. So let's inspect Ximage sync. Okay, so we're going to do a gst.inspect -1.0. And what are we going to inspect? Ximage sync. Okay, so let's come up and look at its source capabilities. Okay, so here's its capabilities. I'm sorry, its sync capabilities. It's an input, so it's a sync. It likes video X raw. Okay, but it doesn't look like that it is going to recognize BGR. Okay, it doesn't list BGR as one of the things. It only likes video X raw. Well, what if all we had was BGR? What if what was coming was BGR and we got to figure out how to get our video X raw BGR, we got to figure out how to get that over to Ximage sync, which just wants the video X raw. How are we going to do that? Okay. Well, what we can do is we can use one of these smart ones. You can do a video convert, or a lot of times if you really want it to figure it out, okay, what we know is this output does not play nice with this input. So there is a really cool converter that is called, so we're going to go between the two exclamation points. This is not caps. This is a new module, and it is auto video convert. And it's kind of like going to see, what am I getting from this guy? What does this guy want? And I'm going to make the magic happen. Okay, there, you see, that worked. So the auto video convert kind of took care of the hard thing for you. So I didn't have to go look at the format coming out of the video test source, and I didn't have to go look at what was needed by Ximage sync. This auto video convert took care of things for you. My experience has been in the real world that these auto converters usually don't work, and you really do have to kind of go in and look at the output of one, look at the source of one, that's the output, look at the source coming from one, and look at the sync wanted by the others, and you got to kind of set those to something that matches. Now, yeah, you want to set it to something you want, but it's kind of got to be two things. It's got to be like what you want and what you can make work. I hope this is making sense. Okay, so let's go again. So what do we like about this? What do we like about this? We like that it works. I've got an input or a source, and I have an output or a sync, and I've got them working together. I kind of like that. But I don't like this little small window, right? So let's start making things more like what we want. So I'm going to come up here, and that auto video convert really doesn't give you any handles. And so what I'm going to do is, after doing that, that's going to get things in the right format for me. But after doing that, I'm going to do kind of a manual video convert. Okay, I'm going to do a manual video convert. Video convert. I'm going to do a manual video convert, and now I'm going to set the capabilities of that. So I put an exclamation, and now comes the caps. I am going to keep it in video X raw. I'm going to set the width equal 1280. I'm going to set the height equal 960. All right. Boom! Look at that. Giddy up. So I made a big window with the test pattern. All right. Now what you might ask is, how did I know to use video convert? Well, you go in and you look at these modules, and you could see that if you looked at the inspection of auto video convert, it doesn't let you change the size, but video convert does. And so I let auto video convert take care of the problem that XImageSync doesn't like BGR, but then I use video convert because it gives me the caps then that I can resize that window. So again, keep in mind that you've got the source, you've got the sync, and you're putting all these little adapters in there until you get something where all the outputs, all the sources play nicely with all the syncs, and you just kind of make the changes until you get these two things that don't match on the ends to begin to match. So I think that is pretty neat. Okay, another thing that we could do is another parameter that we can set with the video convert, or maybe I should just inspect that video convert just to all right. So if you look at things that you can set with video convert, gamma mode, matrix mode, alpha value, alpha mode, chroma resampler, you see there's a lot of things, quality of service, parent. There are a lot of things that can be set there. And one of them that can be set is the frame rate. Okay. Now I ask you, is the frame rate something that you would do with the command with spaces, or is it something you would do after the exclamation? Well, if we look at frame rate, it is a capability. It is not a property. Properties go with the command, go with the module with spaces. Capabilities come afterwards. All right, so if we're going to do the frame rate, we come up like this. Okay, and where we just looked at video convert, so we're in the caps on video convert, and we're going to put comma frame rate equal. And now I will tell you, this is the goofy thing, that Gstreamer wants frame rates as an integer over an integer. So like an integer over a 1. So I'm going to say it is 30 over 1 for my frame rate. And that looks strange. You would say, why not just use 30? Because it wants to see the frame rate divided by 1. And I don't know if that's a way that they could get a floating number, like maybe it has to have an integer, and maybe if you wanted a 33 frame rate, you would put, 100 over 3 or whatever. But let's see if this works. Okay, boom, there it is. And look at that. You see we've got a nice 30 frames per second frame rate. Now you guys know, sticky window problem again. Okay, what you guys know, right, is that on a camera you can only set the frame rate to frame rates that the camera will support, and also you couldn't like run the camera at 10 frames per second and then downstream up the frame rate to 30 frames per second. Now you could slow the frame rate down, but you can't speed the frame rate up because it's actually the camera that limits that. So let's kill this. So let's just look. So let's come in and say that we give a frame rate of 1 frame a second. Okay. So now I want you to look at this. Do you see this gray? 1, 2, 3. So you see that is changing once every second. Now I just can't resist. I wonder if you could make it 2 seconds per frame by saying the frame rate is 1 divided by 2. Let's see if that works. That's kind of crazy. Crazy thing to try to do. 1001. 1002. Yeah, okay. So you can make very slow frame rates by making the denominator, and probably they wanted to work with integers, and that's why they made you do it in this goofy way. Okay, I think that was pretty neat. Okay, what are we going to do here? All right, we play around with different frame rates. We've already done that. Okay, so now instead of using these goofy test patterns, let's do a GST launch 1.0, and I want to launch my Raspberry Pi camera. Again, I am on the Jetson Xavier NX. It will be exactly the same, the Jetson Nano. It will be the same on these different NVIDIA products that use Jetpack. If you're on the Raspberry Pi, I'm not sure exactly whether it would be the same or not. But what you could do is you could look that up pretty quickly. But what it is to use the camera, what is the name of that camera as far as a source? It is NV, like NVIDIA. It is an Argus, ARGUS Camera SRC. That is the name of the Raspberry Pi camera. Probably more accurately, it is the name of the little port that the Raspberry Pi camera is hooked to on the Jetson. It is the NV, is in NVIDIA, Argus Camera SRC. SRC is in source. Okay. Now, I have no idea, so I'm just going to do an auto video convert, and then I'm going out to X image sync. All right. So I've got a source and a sync, and I don't know how what says what and what's listening for what. So I'm going to do an auto video convert because I haven't gone in and I haven't looked at the caps and the properties. Misspelled it. Auto video convert. Boom! That is frightening. That is larger than what you want to see me. It's like too huge and it's upside down. So we're going to Control C out of that, hopefully. Control C out of that. I'm going to have to click over here. At least it didn't close up my terminal, and I will Control C here. All right. What's the good news? So the bad news is we are frozen up again. Good news is I can fix that. Good. What is the good news? The good news is that I did get the NVARGUS camera source talking to the X image sync. Now, let's go over here. And now all of a sudden on this cam set that we did last week, we understand what that is. That is the module that represents the Raspberry Pi camera. There are two little slots on the Jetson Xavier NX, and there's two little slots on the new Jetson Nano boards, and so we have to tell it which one of those we're using. So I set the property, I set the property to sensor ID, which is 0, which is the one when the slots are facing towards you, which is on the right. And then exclamation, I come in and I start setting the caps of that. All right, I come in and start setting the caps of that. So you see, already that is beginning to make sense, I do believe. So what do we like? We've got the camera talking to the display. We've got the source talking to the sync. That's good. But it's kind of like when we do that audio convert, we don't get any input at all on what is going on. So let's try to do a couple of things here. The first thing that I want to do is I want to, after doing the camera source, after launching that, I want to put an NVID convert. That's NIV, that's like NVIDIA, vid conv, like video convert, NVID conv, and then it's a parameter. So I'm going to put flip method equal to. Okay. And then I'm going to go ahead and hand it off to the audio convert. No, I'm going to, on this NVideo convert, I'm going to go ahead and I'm going to set the caps there on that. And the caps that I'm going to set are, I am going to tell it I want video X raw, and I want a width equal to 1280, and I want a height equal to 840. And you guys probably don't know that this bothers me way more than it bothers you, that this thing keeps freezing up. It really bugs me, but I just have so many cameras hooked up. I just overwhelm the bandwidth, and I could reduce down and make things a lot simpler, or we could just live with this glitching out every once in a while. So we are going to do an NVIDIA convert. We're going to set the parameters or the properties to flip method equal 2, which should flip the camera upside down. And then we're going to set the caps. And as we're setting the caps, we're going to change the width and the height to something more reasonable. Boom! Look at that. All right. You guys see that? Look at that. That is the Raspberry Pi camera there. And you see, now we are starting to exercise some control over it. We are starting to be the ones in control. I wonder... Okay, let's look here. I wonder if I could do 640 by 480. I'm just curious. 640 by 480, like that. Yeah, look at that. That worked. Okay, hello. All right. So we are starting to take control. We are starting to take control of our camera. All right. Now let's go ahead and let's do an inspect on GST inspect 1.0, because I'm kind of just throwing these parameters at you and they work. And the reason they work is because I'm in there doing these inspections. NV VID-CONV. Let's look at that. And then if we come up and we're going to look at what this thing can put out, so since we're looking at what it puts out, we're going to look at its capabilities, and we don't want its sync capabilities, we want its source capabilities. It will put out video XRAW with the memory NVMe, or it will put out video XRAW. So we chose to put out video XRAW, and then the parameters that it will take are width, height, and frame rate. Those are the capabilities that you can set. We set width, we set height, and we did not set frame rate. Now, again, you can only set frame rates that the camera knows or that the camera is capable of, but let's just try that just for fun. So on that convert, we are going to comma frame rate equals, and we're just going to have to kind of guess, because you can go in and look at it, but right now I'm just going to guess. I'm going to say, can we do 20/1 like that? Did not like that. Maybe a 21/1. Did not like that. It's kind of not good to just sit here and guess, you know, but no. Okay, I just want to look. Okay, so really probably the better place to set the frame rate. Why do I go off on these tangents like this? But let's see if we can set it as a cap here. Set it as a cap of the camera itself. And so we would set this as video X raw and frame rate equal 21/1. Let's see if that will make it happy. I didn't put a space. I warned you guys about that. Where was that? I'll just have to type it in again. NVIDIA convert. Okay, so we are going to put the exclamation there, and then here we are going to say it is video and over x raw, and then frame rate equal 21/1. Let's see if that will make it happy. Still not happy. Okay, well, the frame rate, it's got to be one that's offered by the camera, and I really thought that that was one, but maybe it is not. But I won't waste any more time on that. What you can see is you'd have to go in and do the inspections but I don't want to slow us down with that. But let me see if we can continue here. So we did that. Okay. So really, probably what we need to do here is we need to come in, and I'm just going to kind of start this whole thing over. And really, we would be better off to come in, and at this point where we have our source, okay, let me think about what we want to do here. Okay, probably right at the source is where is the best place to set these things, because if when you have a source, if you don't set these things, you get further down the pipeline and you're really not sure what you have. And so right here, I'm going to set the caps of the source. And what I'm going to do is I'm going to say, now this time is a little different. We're going to have to make this a string. And the reason we got to make it a string is because it has parentheses. And because of that, I've got to put all of this inside of a string. So I have to put a string because Gstreamer doesn't want to see a parenthesis. So I've got to force it to be a string. Okay. And so we're going to have video over x raw, and remember that this wanted memory colon NVMM, like that. That's what it wanted. Okay. Then it has the width is equal to. Now, let me give you a little pro tip on this Raspberry Pi camera. Don't set the width and the height you want as a capability of the camera, because if you do, all it does is crop. It is putting the video out at 3264 pixels wide and 2464 pixels high. Okay, and if you change it here, it doesn't really change it. It just crops off the part that you didn't keep. What you want to do is you want to grab the whole frame and then you want to convert it. And you might say, well, there's a lot of overhead with that. No, not with this NVIDIA, not with this Xavier NX. It has a huge pipe between the camera and the GPUs, and so it is no problem at all grabbing this whole frame. So we're going to say the width is 3264, and then the height is equal to 2464, and that's just what it is. That is the limit of the camera. So width is 3264, height is 2464. These are caps, so we're using commas. Okay, and now we'll put the frame rate is equal to 21/1. Okay, now I'm going to end that quote, all right, because it was this thing that you've got to force to be a string from here to here. And anytime one of your caps has these parentheses in it, you've got to kind of force it to be a string, because that confuses the parser. If you don't understand it, just take my word for it. You've got to do it if you want it to work, okay? And so now what I'm going to do is I'm going to go to my next module, which is NVIDIA CONV. Why? Because that's the module that has the flip. If this other one had the flip, then I could have done it there, but it's not a capability and it's not a parameter, so I'm going to flip it here. NVIDIA convert, and then the parameter or the property is flip method equal to. Okay, now I'm going to set the caps of the NVIDIA converter. I want to go to video x raw, not with the memory NVMM, because I know that my sync doesn't want that. And so I'm doing the conversion here to get the format right. And now I'm going to do the conversion of width equal 640, comma, height equal 480. So you see what you do? We're grabbing the full frame, and then in the parameter NVIDIA convert, in that module NVIDIA convert, we are changing the dimension as part of the cap, the capability. All right. And then that's all we really need to do. And then just to clean up any formats that aren't working, we will say auto video format, and then X image sync, like that. Auto video format. Oh, auto video convert, I meant. Auto video convert. And then X image sync. Boom. All right. So you see how we're generating this thing? Okay. And also, I'm just curious. I'm wondering if you really need that auto video convert. What if we tried it without that? We are in a video X raw, and I'm not sure about some of the other parameters. Okay, we can do it without that audio video convert. We were close enough that we didn't need that step, so we could take that out. All right. Guys, do you see how this is starting to look a whole lot like this? Do you see how that's starting to look a whole lot like this? I'll give you a heads up. Why was this cam set so difficult? The cam set was so difficult because AppSync, that is OpenCV, that's the app. AppSync wants BGR. And so what I had to do was NVIDIA convert. The NVIDIA converter can take you from NV12 to BGRX, but it cannot take you to BGR. One of its caps, one of its capabilities was not BGR. So I did the next best thing, which was BGRX, and then I used our old friend Video Convert, and he took us all the way to BGR, which then goes to OpenCV, which is the app. And so that's why you have like all of this from here to here would be if they had made NVIDIA convert where it could do BGR, we could have made this a lot simpler. But hopefully this black magic here is starting to make sense, that we're trying to get from what the NV camera produces, which it really likes to output the video XRAW memory NVMM, and we take that all the way to OpenCV, which wants BGR. All right. What do we want to do now? Okay, let's have a little fun here. You can also do some special effects. So we know now that everything is working, right? We know now that everything is working. I wonder if I can make that like 800 by 600. Yeah, I say it's working, and then I go in and monkey with it. It's less dangerous to change this one than it is that, that first width and height. Let's try it like that. That's pretty good. Okay. Let me get this out of the way a little bit. All right. Now, you guys just go in and play with this, but there's all types of cool things. Like I can come, now I know that the thing is lined up the way that it needs to be. So I could add a module that like does a special effect. So I could say like aging TV, and I could add that module in. And boom, do you see how it makes it look like an old... I don't think that's really an old TV. That's more like an old Super 8 movie, right? It's putting the noise and the dirt from the Super 8 movie on it. I think that's pretty neat. And then let me just inspect that. I'm wondering what type of parameters you could put on that aging TV. I did a launch on aging TV instead of an inspect. Inspect. Okay, dust is true. Pits is true. Color aging is true. Scratch lines, you can go from 0 to 20. It's set at 7. Are there any dust is either true or false. Pits is true or false. Color aging is true or false. The scratch lines, you could put a lot more scratch lines in there. So let's try that. Let's come down here and let's put in scratch lines. Scratch lines equal 20, just because we can. I thought I saw scratch lines with a hyphen. Okay, I guess there's a lot more scratch lines there. I'm not noticing a huge difference there. Let's make sure I put that in right. That looks good. Okay. And I didn't see anything else too interesting as far as parameters that we could set. Because most of them are either do you want it or do you not. Let's try 0 scratch lines and see. I just want to make sure that we're actually changing something. I should get rid of the scratch lines. Okay, indeed, it did get rid of the scratch lines. So that command does actually do something. Okay, so let's kill that. And let's see, one other thing that I think is kind of interesting. What is kind of interesting is we could also do, we've done aging TV. We could also do another special effect here. We could come in and we could put in another converter, and what we could put is the converter color effects, and the preset is equal to sepia. Okay, like that. All right, now we're really looking like an old, like an old-time movie. We got the dust, we got the sepia, we've got all of that, and so that is kind of neat. I really like that. I like that a lot. And so you guys can see, I mean, really what you've learned from me is you've learned that you have sources and you have sinks, and then you have these modules. And the camera modules are just sources. The things like a display is just a sink, but the things in between it will have a source, which is, it'll have a sink, which is the stuff coming in. It'll have a source, which is the stuff going out. And then you can either set properties with the module, or you can set the caps after the exclamation point. If you're setting the caps, you got to use commas. If you're setting the properties, you use spaces. All right, and then you go sync to source, sync to source, sync to source, and you string these things together. And so and then the most important thing you learn from me is just that GST inspect to see what it can take coming in and what it can put, on the output, and then just stringing enough of these things together. And I've just shown you a few of the modules. There's a huge number of modules, and so you just got to kind of play around with it. But I do believe that I've given you enough modules now that you can kind of understand what this long string was that we did over here. We go all the way to app sync from the camera. So let's go ahead and look at this. And let me set this larger. Let's see. I'm going to run this and then see what some of the numbers are, and then I'll run it again. Okay, so now I'm going to quit out of that. And then what I want to see here are what some of these 1280 by 720. So I'm going to set this one at 1280. And guys, I hope you have your program from last week. If you don't, go back and look at this from last week. So some of you guys just came in and you learned Gstreamer. Some of you guys are going through the whole series of lessons. If you're going through the whole series of lessons, I need you to go back to the lesson we did last week. And remember, here we set width and we set height. And then that, I'm going to use this one. And I'm going to use the Raspberry Pi camera, which is this one. And then remember how we take these three numbers and we sort of insert them into this long string like this. Okay. But 1280 by 720 should be pretty nice size. So I'm actually changing that Gstreamer command. Okay, boom. All right, now if we look at this, let me try one more time. I'm sorry, I'm such a perfectionist that it really slows us down sometimes. Let me try 1920 by 1080. Let's see if we can even manage that. 1920 by 1080. It's just I want you to see a big view of what I'm doing here. Okay, let's run this program. I hope we can run the program. Oh, that was the wrong size by a long way, wasn't it? 1920 by 1080. I warned you that if you put the wrong dimension, then you can crash the program. Okay, boom, there it is. Okay, I don't know how well you can see this, but what makes me happy is we're controlling the camera in Gstreamer. What makes me happy is we're finding our way with these video converters between inputs and outputs. Let's see on latency. There is maybe 100 millisecond latency, but that is not bad at all. So we're in control of the camera. We're getting the size we want. We are able to go from our inputs to our outputs. We're able to build these streams. We're learning lots of parameters. We are learning lots of cool things. Okay, all this stuff is working really well. What is it that I don't like? Okay, I don't like that if you look at this, do you see all the noise? Like, where is a good place? Like if you look kind of back at the background here, like at the soap dispenser and at the wall, do you see all that white snowy noise? I don't like that. Okay, I also don't like that the contrast of the image is very low. I don't like that the saturation is low. So yeah, I've got an image and I could do image recognition and I could do machine learning and I could do all that stuff like that. But what really bugs me is this is an 8 megapixel camera and we ought to be getting a more visually stunning image out of it than what we are. So your homework for next week is to go in and play with Gstreamer. Okay, it's to play with Gstreamer. And I got a cue out of that one. Okay. Play with Gstreamer. And I want you to come up with a Gstream string that will launch that Raspberry Pi camera. And what I want to see is, I want to see no noise. I want you to get rid of all that snowy noise out of it. I want it to have higher contrast. I want it to be darker, and I want it to have a little bit more saturation. Okay, I want you to create something that is a lot more visually stunning image, because if you come and look over here, do you see how clear this is, how good the contrast is, how good everything is? That's because this is really doing things professionally here. And over here, we are just sort of dumbly launching a camera. And in today's lesson, what we really worried about was just getting from our source, which was the Raspberry Pi camera, to our sync, which was OpenCV, and get all of that thing set up. But now we want to make it look good, and so that's what your homework is for next week, is to go in, get that string to where you got it looking really good. And I'll try to make this a premiere. Maybe you guys could share on the premiere what the cam set string is that you create to get the best stream, and maybe then we could all play around with them and sort of see who came up with the best one. Okay, guys, I've had a lot of fun with this. I hope this lesson hasn't been too tedious. But what I really absolutely hate is I hate to just run out and copy someone's line of code and then launch it and use that and not have a clue where it came from. I think even though today's lesson was tedious, I think you know and understand now what that cam set string is, and you have an ability to go in and make it do things for you. If you didn't see the converter, or you didn't see the effect that you wanted today, at least you know how to go in and find those modules that are available, and then find the caps and find the properties of those modules, where you can make Gstreamer do what you want. Okay, you can make it sing and you can make it dance all the way that you want. Okay, guys, this is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.